Okay, how's everybody doing today?
Wonderful.
Wonderful, good, 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 good. Okay, so we should be able to finish up the right triangle trig that we began yesterday. The big item, of course, is on Monday. You have your first exam of the 6 weeks. Okay. That's a good question. What's on the exam? Pretty much the review material from the sections we've been going over the past couple of weeks. Relations and functions, linear functions, quadratics, exponentials, good combination of those. Some are some purely algebraic, and then some of them, you got some story problems or word problems on there, like the exit ticket or the quiz. Okay. Similar to those. So that's coming up on Monday. It's going to be, kind of an unusual time getting to next Friday. Tomorrow we should be able to go ahead and start with the next lesson, continue trig, and start talking about the law of sines. Okay, and then maybe we'll get to the law of cosines before the end of the week. I don't know, but we test Monday, and then I'm thinking Tuesday primarily will probably be to return the test, talk about any questions you guys might have, and if we have time, we'll go ahead and continue. But then Wednesday, I believe I'm still going to be able to see you, but what's happening next week? Got the SAT, okay, so we'll kind of play it by ear and see what's going to happen. I know it's, what, a 5-hour test? Something like that? Okay. But I know I'm administering it, so I won't be in here. So I do know for sure that it's not a late start day. So if you're not taking the SAT, you do have to show up. So I'm guessing they're still going to have classes probably in the dining hall, places like that. I don't know for sure. But I'm going to a training tomorrow, so I should have a little more information on Friday because it's not till after school tomorrow. And then we will have Thursday, which is a really important day. Why? The IA is due, so we have just over a week left. All right, so if you have any questions, any concerns, please let me know. Hopefully you're already putting the final touches on it, getting everything ready the way you need it. If you are completely done and you want to go ahead and turn it in, okay, please feel free to do so. I'll get it out of the way. But I am taking next Friday the 8th to go sit in the library and just grade all day long. So it's going to be an awesome day. All right. That's all I got until next week. Any questions? No? Okay. Well, let's see. We started talking about right triangle trigonometry yesterday, and we brought up an old friend, SOHCAHTOA, because we're going to be primarily talking about sine, cosine, and tangent. There we go. So sine was the opposite side over hypotenuse. Cosine was adjacent over hypotenuse, and then tangent was opposite over adjacent. And that's the thing about a trig function when you're looking at these right triangles. You evaluate a trig function at an angle measure, and the result is the ratio of the sides of a triangle. And we hinted at this yesterday. We kind of reversed the process. We took the inverse. When you evaluate an inverse trig function at a ratio of sides of the triangle, then you get the angle measure out of it. And actually, we'll be doing some of those today as well. So we talked about degrees, minutes, seconds. Did anybody want me to quickly revisit where to find that information in the calculator? Or do we feel good about that? Okay. We talked about angle of elevation and depression. We'll see those in some word problems today. Okay. I think we got to that last problem and we're good to go now. Okay, so given right triangle ABC, what we have right here, we know because it's a capital, angle C is 90 degrees. Well, we already know that. Now, the lowercase letters, remember, represent the side lengths. So because this is angle A, this would have to be 7, and then B is going to be 12. Okay, so what does it mean when it says solve the triangle?
Find all the sides and angles.
There you go. Find every missing side and every missing angle that we have. Okay. So in this one, we could go ahead and use inverse for the first time, but let's go ahead and take a look at the side length. We don't actually need any kind of trigonometry to help me find that because it's a right triangle, so I could just use what? The Pythagorean theorem. Remember, a squared plus b squared is equal to c squared. So in this case, let's just say that h represents my hypotenuse, or you could go ahead and put the segment AB, perfectly fine. So let's see, 7 squared plus 12 squared is equal to h squared. So that's going to be 49 plus 144 is equal to h squared. And what is that? Okay, I heard 193. Okay, is equal to h squared. And of course, to find h, we do what? Take the square root. Okay. Now, is 193 a perfect square? No, it's not. Now, is there any way we could simplify it? Can I break 193 down? It's definitely not even, so 2 is out of the picture. Okay. Will 3 divide in there? No, 3 is not going to divide in there. No 4, no 5. I'm thinking at first glance, it's probably not going to simplify unless you guys are seeing something I'm not. Okay. So I would go ahead and say it's just the square root of 193. No, on these, probably go ahead and stick with the simplified radical unless it was specific and said round to a certain number of places. Okay. All right. Good, 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 good. Okay, so now we got to go ahead and start figuring out what angles A and B are. And really, we only have to take the inverse once. Let's say we want to know angle A. Okay. So we have all 3 sides, so technically we could go ahead and use any of those 3 trig functions. Okay. Evelyn, what do you like? Sine. Okay. So let's say sine of A. Now remember, sine's ratio was always going to be the opposite over the hypotenuse, right? So in this case, what would the ratio be? There you go. The opposite 7 over the square root of 193. Okay. And all we have to do now is just go ahead and take the inverse. Now, there's a lot more involved with inverses. In fact, does anybody remember, and I'm looking at my pre-cal students, what's the interval that the ratio has to fall into in order to be accepted by inverse sine? Been a while. Do you guys remember basically the domain of sine inverse? No. It's one of those things you're not going to be held to. I was just kind of curious to see if anybody would remember it. But when we take sine inverse of this ratio is going to give me angle A, well, this has to belong to the interval -1 to 1. Okay. Like I said, that's nothing that you're going to be expected to know in IB. Every problem you're given should work out nicely, but there is a lot more going on with the inverses than what we're just talking about here. We're basically just scratching the surface. Okay. Does anybody remember what the range would be for sine inverse? Just FYI. Curious? It's in 2 quadrants on the unit circle. What 2 quadrants will sine inverse have outputs? Okay. It is quadrant 1 and 2. So it's only between -π/2 and π/2. You can only get an answer between that. Oh, you didn't understand the question, but you remember that? There you go. All right. Okay, okay. So let's actually see what the measure of angle A is going to turn out to be. So sine inverse, let's see here. So I'm going to come on over here. Now your trig functions are going to be right here where it says trig, between equals and 7. So the top row is all your trig functions. The bottom row are the inverses. So sine inverse of 7 over square root, what was it, 193? Okay. So if I go ahead and push enter, so we're looking at about 30.3 degrees. Okay. So let's go ahead and say we take it to 1 decimal place. So if that's 30.3, well, in order to find angle B, I mean, we could go ahead and set up another trig equation and take the inverse, but if I already know 2 angles, all we got to do is subtract. Okay. In fact, I'm going to go ahead and take 90 and subtract the answer we just got. Yes, please. Okay. There you go. So let's say that angle B has got to be 59.7. Is everybody okay how I found angle B real quick? Okay. Thank you. Jocelyn, she's outside. Okay, Jocelyn, this is actually for you. Okay. Okay, so let's see here. So A was 30.3 degrees, and this one was, what was it, 59.7? Okay. And there we go. Okay. This coming back to a lot of you? Remembering this from geometry? I don't know how far you went in geometry. Did you take the inverses? You did? Okay. All right, good, good, good. All right. Well, let's take a look at this next one here. It says, given the right triangle ABC, where we know C is 90 degrees, solve if side C, okay, so the hypotenuse is 24 units. We know angle B is 19 degrees, 12, what is that? Minutes, okay. And then the two tick marks are going to be seconds. So this one we'll go ahead and convert real fast. Was there some place on the calculator where we could just input those values? Okay, catalog, that was if I wanted to change it to degrees, minutes, seconds. But if I have degrees, minutes, seconds, if I go ahead and push this button right here between 9 and the catalog, remember it's this one that's already highlighted. Second row, second icon. Okay. And in fact, what was the value here? 19 degrees, 12 minutes. 19 degrees, 12 minutes. And I'll just go ahead and plug in 0. I actually don't think you have to plug in the 0, but I'm going to go do so anyway. Okay, 96 fifths. Okay, so we're looking at 19.2 degrees. Would everybody agree? Okay. All right. Okay, so that is angle B. Thank you, sir. Okay, it's 19.2. Okay, so what we're looking for is angle A and then the two legs of the right triangle. Okay, let's see if we can get some folks up here to help me out with these. Who would like to help me find the next item? And I'll let the person choose what they want. So many hands. I know so many people out there are probably thinking, wait a second, I can actually go up to the board? I say secant's a trig function. It's funny. Oh, Spencer, you want to do it? There you go. All right. Okay. So what are you going to go ahead and find, sir? A side length or the angle?
I'm going to find side.
Okay. You mean BC?
Yeah.
Or so a little bit. Okay, I see what you're saying. I'm sorry. Okay. So AC. So he's going to use sine of 19.2 is equal to the opposite, okay, over 24. Yes, the hypotenuse is 24 units long. Okay, so all we have to do is multiply through by 24. That will cancel the denominators. So we just need to know what is 24 times the sine of 19.2. Okay, and what should I be getting, Spencer?
7.89.
7.89? Okay, there we go. All right. So how would you guys like to round that? 7.9? Okay. All right. So we'll go ahead and say that that opposite side to B is 7.9 units. There you go. Okay. All right, let's get somebody up here for the next side. John, you want to do another one? You want to find the angle for A? Sure. There you go. Bless you. Okay, so we're going to take 180 and minus the 109.2. Okay.
Should be 70.
Okay. I agree. There we go. Okay. 70.8. Now the last one, we'll set up a trig function, or we could use the Pythagorean theorem. Okay. Who would like to come on up and do this last one? Okay, John, you were the last person to come up. Who would you like to see do this?
Shelly. Michelle.
All right. So will you use the Pythagorean theorem or will you use a trig equation? The theorem, okay. So 7.9 squared plus x squared, okay, equals 24 squared. Oh, you want me to type it in too? Yeah, I can do that. Okay, so I'm going to go ahead and streamline this. So I would subtract that value over. So again, while we said 7.9 on our paper, I'm going to go ahead and use the approximate value here. So x squared would equal this, right? Okay, but I'm still missing something. Now I need to take the square root of that. Okay, perfect. So the square root of this right here, and what should I be getting? 22.7. So that's perfect. Okay. Yeah, sure. There we go. 22.7. Okay. All right. Okay, good. And now let's start looking at a couple of word problems here. The foot of a ladder of length 6.5 meters rests on horizontal ground. Its top rests against a vertical wall. The ladder makes an angle of 50 degrees with the ground. Okay, so let's go ahead and diagram all this, especially with these trig problems. If a picture isn't given, I always recommend, drawing one. Yes, ma'am. Oh, really? Okay. What number is that? Okay. I'll charge those up tonight. Close it. Oh, wow, that really is. Okay, so let's go ahead and draw a diagram. So here's the ground. Let's say we got the wall right here. Okay, so we got a ladder that's leaning against the wall. So what do we know about the ladder? Okay, well, it is going to be the hypotenuse because the wall and the ground is going to form the right triangle. So the length of the ladder is the 6.5 meters, right? And we also know the ladder makes an angle of 50 degrees with the ground. So this would be 50 degrees right here. So it says calculate the height above the ground reached by the top of the ladder. So what we're talking about from the top of the ladder down, that's what we want. Okay. All right. So Carolina, help me out with this. How would I set up an equation to help me find that height? Sine, cosine, or tangent? I'm sorry? I'd probably go sine again. Okay. So sine of what? Go ahead and tell me what the equation should be. Sine of 50 equals. What would you like to use to represent as a variable? Just x? Okay. So let's say that's x. So x over 6.5. There we go. Simple trig equation. Got to multiply through by 6.5. And let's see what that ultimately will give me. Let me get rid of this. So 6.5 times the sine 50. Okay, so what should I get? Okay, 4.97. In fact, that's really close. You might go ahead and make an argument for just saying 5. So would you like me to put 4.9 or 5? Let's say 5. So let's say x is about 5 meters. Okay. There we go. Okay. Questions? Okay. Now, let's go ahead and take a look at this next one here. It says the ladder is moved so that its top reaches a height of 4.5 meters above the ground. So the diagram is going to change slightly. Okay, so here's the ground, here's the wall. Okay, but it's changed so that this height right here, okay, is 4.5 meters above the ground. So that is 4.5. We know the length of the ladder, that remains unchanged, 6.5. So calculate the angle that the ladder now makes with the ground. So let's say that's theta. And remember, any variable could really be used to represent measurement, but theta is probably the most common one. Okay. So how am I going to go ahead and do this? I'm going to have to do something. Starts with an I. I'm going to have to take the inverse. Okay, and you want to use sine? Okay. Is there any way I could use another trig function? You could, if you wanted to, actually go ahead and use these two side links to find the base here, the distance from the ladder to the base of the wall, and then you could use any of the trig functions you wanted. Do we want to go ahead and do that just so we can use something besides sine, or Emily's like, nope, we don't need to do that?
Well, it's just more work.
It is, but with math, it's fun, right? All right, so somebody tell me what my equation would be then. Sine of what? Okay, well, sine of theta, because we're trying to find that angle, equals, what'd you say, Cindy? 4.5, the opposite, over the hypotenuse, 6.5. Okay. So we evaluate a trig function at an angle, and we get a ratio of sides. So then we evaluate an inverse trig function using a ratio, and that's where I get an angle measure. Remember, the idea of the inverse is just to switch the quantities. Okay, in this case, the input and the output. So let's see what that's going to give me. I'm going to take trig, sine inverse is right here. Control divide, bless you. 4.5 over 6.5. So I'm looking at about 43.8 degrees from the ground. Okay, easy enough, 43.8. There we go. Anybody having a hard time? Okay. Anybody think I'm trying to trick? Trick. That one's a little meh. I have another one, but it's not really. There's no scenario where it really comes up. Like silly student, trigs are for kids. See, that one's better, but there's really no scenario where that kind of comes up. You know? Yeah. I feel it's just another day where y'all are just staring at me. There you go. Okay. What's that, Eli? Oh, I thought he was trying to make a pun or something. No, okay. Oh.
It's been an off day for Eli.
Got it. Okay. Yeah, there you go. There you go.
Mom, I'm gonna have to tell you what you
Well, you guys were having a pretty serious conversation about birds when you walked in. So. Something about electrocuting birds. I don't know what you were talking about.
Yeah, Spencer, what's up with that?
No.
No, so
You're supposed to have a bird in your bag?
no, that's out of
John
context.
just pulled out a chicken leg.
No, there's no bird in my snack pack. There's only snacks in my snack pack.
So wait a minute. How are we connecting a bird in his bag to being electrocuted?
There was a bird in someone's like shirt or bag or something that John saw. So we draw a
Here?
line from
Somebody actually had like a bird in their bag?
I don't know. What did you say was?
It was in the cafeteria.
Really?
Yeah.
So
Okay.
then we draw a line from that to Eli's cousin Annie's canaries or parakeets.
Parakeets.
There's no vet in Lubbock that are clipped beaks, so they're like growing down and eventually will like curve into the chest,
So it
kill them.
Well, that's why you get like the cuttle bone or something, right?
What?
They sell those. It's like a white shape. I don't know what it is, but they like gnaw at it and it cuts it. It keeps that from happening.
Well, why didn't they get that?
I don't know your family. There's something you can get that the birds can like gnaw on to prevent that from happening.
But you know what it's called?
I thought it was called a cuttle bone or something, right? Or I don't know. I could be wrong, but I'm pretty sure there's some kind of little item that you could use.
Oh, it is. I found it.
There.
I'm gonna text her a picture and be like, "Get this for your birds so they don't die."
But by that time, the bird won't be able to get its beak on there. But,
What if the birds don't know how to use it?
Just tell them.
well, I think it's like instinct, yeah.
Yeah, it's just
Because rats have to gnaw on things the same way because their teeth will continue to grow in case they keep those in check. Yeah.
beavers do the same thing.
Yeah. Okay. So there you go. You're not only learning about math, we're learning about nature. There you go. This class covers everything. Okay. So next example. An observer standing on the edge of a cliff 82 meters above sea level sees a ship at an angle of depression of 26 degrees. How far from the base of the cliff is the ship situated? All right. Okay, so who would like to come on and make some air? You already raising your hand? All right. Okay, so if you'd also go ahead and draw us a little diagram as well. Okay, so there's the cliff. So there's the water. Okay.
There's a ship. So this is 82 meters above, and this is 26 degrees. So then now we're trying to find this.
Okay, now be careful because it does say we see the ship at an angle of depression of 26 degrees. So this means the person is standing on top of the cliff and they're looking out, so they have to look down to the ship.
Yeah.
No.
The top of the line is so like top of the triangle.
So if we were to extend this, if this represents the line of sight, then this would be the 26 degrees. Okay, I got you. Thank you. So what would that angle that we just had actually be?
Oh, so this would just create a right. So that.
Okay, so it'd be 64 degrees. Okay.
So then this would be a tangent function. Is equal to, and then it would be adjacent. It would be opposite over adjacent.
There you go.
So
Because this one is not using the hypotenuse. We're using the two legs of that larger right triangle. Okay. Okay. And let's see what we got here. So I'm going to go ahead and say 82 times tangent. Okay. And you got to be careful with tangent. I mean, we're not just talking about a guy who spent too much time at the beach. Tangent. Okay, well, I forgot what was it. 64. There we go. Okay. I worked so hard on these jokes. Thank you. Thank you. Okay, so I'm getting about 168.1. What are we talking about here? Meters. So about 168.1 meters. Thank you, Samir. All right. 168.1 meters. What?
Tangent's like a professional way to say guy. I said, is it a tangent only if he's being professional, but if he's being casual, it's just tan guy?
Tan man.
I've never been in
Get out of here,
just trying
Eli.
to participate.
Oh, lordy, lordy. Okay, last problem, and we are done. All right. So this one says, Ingrid measures the angle of elevation from a point on level ground to the top of a building 120 meters high to be 32 degrees. She walks towards the building until the angle of elevation is 45 degrees. How far does she walk? Okay, so I'll go ahead and get the diagram, and then we'll see if somebody will be willing to come up here. Okay, so here's the level ground. It's horizontal. So here's the building. And we know that the building is going to be 120 meters tall. Okay, so we've got 2 points on the ground from which she's standing. So the first point, she's looking up to the top of the building. We have an angle of elevation that's 32 degrees. Then she walks a short distance. She looks up again, and now the angle of elevation is 45 degrees. Okay, so what we're wanting to know is how far a distance did she walk? So basically, you've got two right triangles, one inscribed inside of another. Okay, so how can I figure out what that is? Who would like to come on up and work this last problem? Eli, you want to do it?
Yeah.
All right, okay, come on up and wing it. A few people caught that. I said, come on up and wing it. We were just talking about birds.
Oh, I was trying to figure out where in the problem it
Yeah. Well, I'm sure it's a tall building. There's going to be birds on it. Sure.
I feel like it's
Not about it.
I don't know the rule.
They'll be in his snack bag. Okay.
Okay, sweet. So, okay. So I think the best way that I did this was if we find the length of this side of this small triangle, and then we find the length of this side of the big triangle, we can figure out what this is. And so
By doing what?
By figuring out the length of this,
So the base of the smaller.
the base of the smaller subtracted from the base of the bigger.
There you go. That'll give me the distance she's walking. Okay, perfect.
And so what we've recognized first is that this is also a 45-degree angle.
Mm-hmm.
And so this length is also 120 meters.
So there you go. Actually, we don't have to set up a trig function because we did recognize that this is a special right triangle. Very good.
And so now that we found that, if we just find the length of this big base, we can find this length. So if we just do a trig function.
So which one are we going to use? Sine, cosine, or tangent? Tangent. There we go.
If we do the tangent of 32, that'll equal 120 over x.
And x is going to represent the base of the bigger triangle.
Yeah, and
Okay.
so if we cross multiply, we can get tangent of 32 times x equals 120.
Okay, so in this case, x would equal what?
And then in this case, x would equal 120 over the tangent of 32.
There you go.
So
Good.
20 over the tangent of 32.
So is everybody okay with what he's doing, his reasoning? No questions?
Can I move this down?
Oh, yeah.
Perfect, sweet. Then we put that in the calculator. We should get 192.04.
Okay, for the base of the larger triangle.
Yeah.
Okay.
I'm just gonna, and since it's 0.04, is it okay if I just keep it as 192?
That's okay.
And then when I did the actual calculation, I subtracted 120 from that. So if you just do 192 minus 120, you should get 72. And some change. It's like 72.04.
Okay.
So that's 72.
There we go. That is exactly right. Okay. Any questions? Anybody not sure what he did? We're good to go. Okay, good. All right. And I was trying to remember when Gabby walked in today, we agreed Friday is when the homework was due? Okay, so you still have a couple of days, even though how many people are probably already done with it? Quite a few people, okay. So we'll turn that in on Friday. That's 2 days. Tomorrow we are going to start the law of sines and see how far we can get, because there is, do you folks remember my pre-cal students, the ambiguous case? Okay, well, we will have to go over that as well, and then we'll talk about law of cosines, and again, we'll just see how far we can get. But this material, right triangle trig, law of sines, law of cosines, will not be on your test. We'll more than likely have some kind of quiz or something, but there you